Okay, so the first chapter. The book and so on are all in the syllabus, okay, and it's on my page, so you can just get those information from there. Chapter 1 will be introduction of basic concepts, experiments with random outcomes. This is the first chapter, and the first section will be sample spaces and probabilities. Okay, so we will just introduce basic concepts. Bu arada kamera diğer tahtaya bakıyormuş. Okay, şöyle yapayım. Tamam. So what's the sample space? Let me start from that. The sample space omega is the set of all possible outcomes of the experiment. Suppose you make an experiment and you just list all possible outcomes of this experiment. Elements of this set of the sample space are called sample points. Sample points, and usually denoted by omega. So the sample space is big omega, and samples are omega. Okay. The second concept we will define is subsets of omega are called events. The collection of events in omega is denoted by curly f. Okay. So for example, if the experiment is flipping a coin, then there are two outcomes. It is either tail or heads, right? So in this case, omega would have just two elements, yazı tura or tail or head, and subsets of this two element set will be empty set or one element subsets or the whole set. So they are called events. Okay. I'll give several examples, but before I start listing examples, we have the definition of probability. So what's a probability or the probability measure? The probability measure also called the probability distribution or simply probability, which we will denote usually by P, is a function from F, the space of events, into real numbers. Each event, okay, each event A, which is an element of this set of events or collection of events, has a probability denoted by P of A. Probability of this event to happen, okay? And P satisfies the following çok yaşa bu arada following axioms known as Kolmogorov axioms. So he is the first mathematician who axiomized these in 1930s. And let's see what are the axioms. Anlamadığınız bir şey olursa hani durdurup sorun.
May I ask? I want to understand clearly. Is the F power set of omega? All possible subsets?
No, that's why I just said collection. If actually in this course it will be the power set of omega, because we will consider either finite or countable sets. Omega will be either finite or countable. In that case, this will be the power set. But in general, it will not be the power set. It is something much smaller. That's something Özgür is going to teach this semester. So that's called measure theory. So you cannot, this thing probability is a measure. But if you have an arbitrary set, for example, in the real numbers, okay, you may not measure it, okay? So not all sets are measurable. Of course, I have to define what's a measure and so on, but so measuring subsets of real numbers is a delicate business. But in this course, we will not enter into that business at all. We will consider sample spaces which are either finite or countable, and in that case, this F will be the set of all subsets. Okay. Okay, let's list Kolmogorov's axioms. The first one is probability of any event is something between 0 and 1. 0 means that event will not happen, or actually I shouldn't say will not happen. The probability that this event is going to happen is 0. But it doesn't mean that it will not happen. Okay? And probability, if it is 1, it means it will eventually happen. But when it will happen, or again, it's not something certain. That's why we call this probability. Probability is 1, doesn't mean that it will certainly happen. But the probability is 1. So 100% it will happen, but it doesn't mean that it will happen. Okay? Yani olasılığın %100 olması bunun gerçekleşeceği anlamına gelmez. Olasılığı %100 hesaplıyoruz, %100 çıkıyor. Evet. Ha, şunu mu? Tamam. Özür dilerim. The second axiom is the probability of this event is 1. This is the set of all outcomes, and of course the result of the experiment is one of the elements here. That's why the measure of the whole sample space is 1. Okay? Yani bugün haftanın şu günlerinden birisidir. Pazartesi, salı, çarşamba, perşembe, cuma, cumartesi, pazar. Değil mi? Bu doğru yani. Onu söylüyor bu da. Okay. Third one, if A1, A2, A3, and so on is a sequence of pairwise disjoint events, then the probability of the union of these events, here it is important that this is a countable union, is the sum of the probabilities. Okay? Here, of course, it is important that these are all disjoint subsets. Okay? Yani you flip a coin. If it's a fair coin, then with probability 1/2, it will come heads. With probability 1/2, it will come tails. And the sum of the two probabilities is just 1, right? So the probability that the coin will give us heads or tail, right? There are two disjoint events. The probability of the union is just the sum of the probabilities. So 1/2 plus 1/2, which is 1. Yani para tabii dik de gelebilir ama onu olmayacağını kabul ediyoruz. The triple, so we have this sample space, the set of results, outcomes of the experiment, the set of events, which is a collection of subsets of this samples, results of experiments, and the probability measure. This triple is called a probability space. Okay, so when we say a probability space, we will mean such a triple. Okay. Okay. I will use the notation of the book so that you can follow from the book also. So that was definition 1.1. Did I write definition 1.1? No. Okay, so yeah, so this is okay, so this is definition 1.1, and now fact 1.2. If A1 up to AN are pairwise disjoint events, finitely many disjoint events, then by axiom 3, we have this A1, AN. This union is just this. So you don't have to take an infinite sequence. Actually, you may just consider this as an infinite sequence of events by letting AN plus 1, AN plus 2, and so on are all empty set, and the outcome of the empty set is 0. Okay, you should of course ask why this is the empty set. The reason is the following. This is N. Oh, yeah. Okay, yeah. The empty set, I forgot. Right, is that, yeah. Here, we should also include this as a part of the axiom. The probability of this space is 1, and the probability of the empty set is 0. Okay, so these are 3 axioms. Okay. So let's see some examples. Example 1.3. Flipping a fair coin. In this case, our sample space, the results of this experiments, right? When you flip a coin, you either get heads or tails, right? In Turkish, we say yazı tura, right? And what is F? The set of all events. We will just take all the subsets of omega. So empty set. We have this event. We have this event, and we have also omega. The set, in this case, this is just the power set of omega. So in this course, as I said a minute ago, F will be usually the power set, the set of all subsets. Okay? But when it comes to uncountable sets like real numbers, then the story is completely different, and we will not enter to that in this course. What is the probability function? So it's a function from this into real numbers. We already know that the value on this set is 0. It's by the axiom. And the value on this set is 1. Its value on this here, since we said fair coin, so P of H is 1 over 2, and P of tails is also 1 over 2. If it's not a fair coin, then of course, you know, this may be different. Maybe this is 1 over 3 and this is 2 over 3. Okay? Sorusu olan var mı? Okay. Ne kadar zamanımız kaldı? Okay. Okay. Another example. We will actually revisit these examples over and over, you know, when we introduce new concepts. So, rolling a standard 6-sided die. Bizim derste de ya zar atacağız ya yazı tura yapacağız. Yok, herhalde 6 yüzlü. Şeylerde var ya 12 yüzlü vesaire de yapabilirsiniz. Evet evet, burada şey yapacağız. Fair şey olacak yine. Okay. So in this case, so we roll a die and then the top, the number on the top is the result of the experiment. So what are the results? It can be anything between, right, 1 and 6. So this is our sample space, and our set of events is just the power set of this. All subsets of this, of course, we have 32 subsets, right? 2 to the power 6. So 30, yes, 64. Yeah, 2 to the power 6. So I will not list them. And we have this for any omega in omega. Okay. So for example, if A is the set of even outcomes, so A is this event that the outcome is an even integer. What is the probability of this event? Well, this is a union of 3 disjoint events, right? I can just write it like this. 2, 4, and 6, right? And by our axioms, this is just the sum of these probabilities. But by our assumption that this is a fair die, therefore all these probabilities are 1/6. So this is just 1/2. Okay. Okay. Now now let's consider an unfair coin. Assume that for an unfair, yani hileli para, the heads is 3 times as luckily as tails. So, yani tura gelme olasılığı yazı gelme olasılığından 3 kat fazlaymış. In this case, of course, what is the probability of heads? For simplicity, I will just write P of H. But actually, we put here a subset, and H is not a subset. I should write actually like this, but that's not practical. So we will just abuse the notation and write P of H. So this will be just 3/4. And what is the probability of the coin gives us tail? It is 1/4, right? So heads is 3 times as luckily as tails. Sorusu olan var mı? Okay. Hilelilerden başlamışken zarlarda da bakalım durum nasıl. Suppose that for a loaded die. Böyle deniyormuş. Ben de bilmiyordum. Yani hileli para. Okay. A 6 is twice as luckily as any other number. Of course, in this case, what happens? If you just think for a moment, so the probability that 6 comes is twice the probability of any other number. So it should be just 2/7, and the rest will be 1/7. So the probability of 1 up to 5 is just 1/7, and P of 6 is just 2/7, so that this probability is twice of any other probability, and the sum is of course 1, right? We come up with these numbers using the axioms. The total sum should be 1, and one of them is twice of the remaining ones. Therefore, this should be the probability distribution, so that P of omega is 1. Okay. Şöyle yapayım. Olasılığı anlamak bence bizim açımızdan kolay gibi geliyor. Yani böyle sanki e, hani beynimizde olasılıkla ilgili böyle bir modül var gibi düşünüyorum ben. Hani bir sürü şey bize çok doğal geliyor. Hani böyle matematiksel olarak ifade edince sıkıntılı ama hani okuma yazması olmayan bir insan bile yazı turayı anlayabiliyor. Değil mi? Ona itiraz etmiyor. Yani para hileli olmadığı sürece tabii ki. Hani bu insanların böyle hani bir yerde doğuştan anlayıp hissettiği bir şey gibi düşünüyorum. Tabii böyle yani matematiksel olarak formüle edince karışıyor işler ama hani o şeye güvenmek lazım. E, e,
Hocam şey bile keşfettim işte. Hileli zarla oynuyorlar. Paralel desteği. Hileli olduğunu dile getirmeden önce beyninde bazı yerler şey yapmaya başlıyor. Yani kendisi bilinçli olarak farkına varmadan önce bile tam anlıyor onu hileli olduğunu.
hileli olduğunu anlıyor. Olabilir. Okay. Let's do one more example. Sometimes I will skip some of them. So if the numbers are not consecutive, you know, maybe I will omit 1.7 because, you know, I find it just too easy, or we already saw a lot examples. Okay, now this time we consider an experiment. We roll a pair of dice of different colors. Suppose one of them is red, is say one blue and one red. Then the sample space, okay, we give different colors so that the outcomes are ordered pairs. Suppose I write first the blue, you know, the number on the blue die, and then in the second coordinate I write the number on the red die. So the outcomes are pairs. Here, each ij, of course, is a number between 1 and 6. Okay? The first one corresponds to blue die. The second coordinate corresponds to the red one. So this is our sample space. Okay. Buraya yanlış yazmışım sanırım. Okay. Assuming that, you know, suppose each die is fair, then the probability of any you know, outcome is what? The first one, the blue one, comes I, the red one comes J. What is the probability of this? Well, the probability of this is 1/6. This is another 1/6, and we multiply, right? So this is just 1/36. Okay. Okay. Kaç oldu saat? Var mı? 5 dakikamız var. Tamam. Well, if D is the event, suppose the sum of the two die is 8. Suppose this is the event, okay? The sum is the sum of the two die is 8. Then, well, what is this set as a subset of omega? For the sum to be 8, we don't have 1, 7, right? We have 2, 6, and then 3, 5, and then we have 4, 4, and then we have 5, 3, and 6, 2, right? These are all different events. The blue die comes 2 here, 3 here, and so on, and here the red one comes 2, okay? And what is the probability of this event? Well, each one has this probability, and we have 1, 2, 3, 4, 5, right? Each one has the same probability, so we will just add this number 5 times, right, by axiom 3. So this is just 5 over 36. I just realized in my notes that I wrote here 1 over 6, not 1 over 36, so don't get confused, it's my mistake. Okay. All right, let me do one more example and then I'll stop. Okay. This time, we assume that this is 1.7. Assume that a fair coin is flipped 3 times. Let's encode 0 for heads and 1 for tails. Then the sample space will be what? Sample space. So we flip once and then we record it, and then we flip again, and then we flip again. So we get 3 numbers which are either 1 or 0. So I have just you know, this 1, 0, 0, and up to what? 1, 1, 1, right? How many elements this will have? Of course, we have just 8 triples, right? 2 to the power 3, 8 triples. And since it's a fair coin, the probability of any event, you know, omega will be just 1 over 8, right? For any event. sorry, for any sample. Okay. And from this, you see that if I just repeat an experiment n times, then the sample space will be just products, right? So let me just write here more generally, if n experiments are performed, not necessarily actually the same experiment with sample spaces A1, A2, AN. So we have n many experiments, and these are the sample spaces of these experiments. Then the sample space of the combined experiment. So you may flip a coin 3 times, or you may flip a coin 2 times, and then you can roll a pair of dice. So 2 different experiments. You can do this as many times as you want. Then the sample space is what? Of course, it will be just the Cartesian product of this sample spaces. Okay. Let me stop here. Şunu bir kapatayım da.